Hello, everyone. Welcome to this week's episode of ClueCon Weekly. This week, joining us is Jeff LaCoursiere, CTO of StratusTalk, and a longtime expert in, well, many things from software to development and a lot of business too. So I'm glad to have someone with your curriculum on the show. Thank you for joining us.
Thanks for having me. I appreciate being here.
Would you like to give us a quick introduction about yourself? You have such a long career that there's a lot of interesting stuff in there.
Yeah, I'm getting old. I'm feeling old. In the tech industry, I'm probably ancient. But I am lucky, I think, to be doing the same thing that I was doing when I got into college in 1988. So I went to Boulder in Colorado, and I was on the Unix administration team as a freshman, part of a scholarship that I won from Steve Wozniak, actually.
Oh, wow.
And I got my Unix chops back in 1988. So it occurred to me here in 2023 that I am still typing the same commands in a terminal window that I was doing in 1988. I'm literally doing the same things. I manage hundreds of Unix servers.
Hasn't changed too much. Yeah, you're right. It's so many things are different, but the core isn't that far.
No, it's not. TCP is the same, literally, as it was back then. I'm typing SSH instead of Telnet, but everything else is pretty. That's amazing to me. In a world that's changing so quickly, that could be true. Anyway, telecom has also been my background almost since day one. So right out of college, I joined a company that at the time was using Microsoft Windows. No, it was using DOS actually. DOS and an application.
Oh, wow.
Yeah, it was a DOS application that used a dialogic card to perform PBX functions. And we were coding kind of specialized IVRs for companies, way back in the day. This is 1991. There was no VoIP yet. This was all analog and being done on dedicated PC hardware. So my telecom IVR days really goes back a long ways. I went from that company to starting my entrepreneurial career. So that was kind of a startup that I had joined. And when I left Colorado and left that company and moved to Dallas, Texas, I started an IVR company with an investor. And we hired a bunch of people and salespeople. We went after trucking companies, trying to get automated dispatch into these companies. So when I left the company in Colorado, we decided to start completely from scratch. We didn't buy a license of that DOS software. I was still a heavy Unix guy and didn't want to use DOS. So I convinced the investor that we would start absolutely from scratch. We got SCO Unix installed on a PC, used the dialogic card again and their SCO drivers, and I hired 4 programmers, and we put our heads together and wrote an IVR, really a full PBX. It didn't have a lot of the switching capabilities, but it had all the IVR capabilities and a database backend to FoxPro and all of this stuff. And we had a fully functional trucking system that we sold for a couple of years. Anyway, that kicked off my entrepreneurial career. And I've now started, I think I'm on company 30 or 31.
Oh, wow,
Most
really?
have gone nowhere. A couple of them have hit big. I've been running this StratusTalk company now since 2012. I'm the CTO. I've got a business partner that is the CEO. He handles most of the business side of the company. And it's really the same stuff. It's the same stuff I've been doing for nearly 40 years now. We have gone through...
things have improved. Databases are better. Some interfaces are better, but it's not that. You're right. It hasn't really changed. It's all incremental if you've been in it for a while.
I ditched all the analog stuff. We don't do a lot of on-site PBXs anymore, although we still do them for hotels. Most of our stuff is all hosted. We've, as of probably 5 years ago, moved everything to AWS. So we're out of our data centers now. But we've gone through multiple iterations of architecture We started out, of course, in the late 90s and early 2000s installing regular PBX systems that we built out of PCs, and they were running Asterisk. We migrated from that to running free PBX on top of it, and we've been doing that ever since, really. So we're a heavy free PBX shop, got hundreds of these instances running. We went through a phase where we used LXC for our architecture and containers. This was in, this is probably 2010-ish. So we migrated our customers that were on-site PBXs, which were mostly in the Virgin Islands, by the way. So we actually started this particular company in the Caribbean. And those customers have a real issue with power. So the power goes off all the time. And if you've got an on-site PBX, that means you get ring no answer. There's nothing to pick up the phone. So we convinced these people that rather than that, move to our hosted system. And for that, we gave them an LXC container with free PBX kind of already installed in it. And then if your power goes out, it's going to be answered by our system that's up stateside. And, if you're available, we'll transfer the call down to you. But if you're not, your customers will still hear your menu and be able to be transferred to cell phone backups and other things that will be automated. That was a big hit. So we migrated all of our customers to this container-based solution, which went for a really long time. We were running in data centers at the time. We had a data center in DC and another in Chicago. But it got a little bit unwieldy, and there are issues with, if you've got 50 containers running on a host with LXC, there wasn't a lot of good separation yet in C group. So one customer really could, a bug could take the entire machine down, take 50 customers with it. So we were searching for a better solution. So around 2016 or 17, I started looking at AWS. I wasn't super happy with the idea of using VMs. I felt like timing was everything for our streaming audio. And I wasn't convinced that AWS had mastered the timing for the VMs running on hosts. And I think I did some trials like around 2015 and proved it to myself that they weren't, and that I didn't want any part of it. But it got worse and worse with the 2 a.m. phone calls, the alerts from the data center, the having to drive in the middle of the night, downtown.
The timing stuff was actually the main problem for many at the time. Like I do remember, so I've been an application, I've always been a pure software developer for a long time, so it's slightly different path from yours, but for a long time when I started using Asterisk and FreeSwitch, I kept hearing people, you should not be running on VMs, and I have actually ignored that for most of the time, and nothing ever happened. So I feel like it was a short period where there was an actual timing problem, and it was a very long-lived, and it pertained to some specific types of things. Like if you're only doing SIP, you will never have issues.
Yeah. So, it bit us for a while. It kept me from going to AWS for probably a few years. My little bad experience. But it became unavoidable, really. As we grew, it just, running a data center is its own job. And I was up against either hiring somebody to be a data center manager or moving to AWS. And actually, we tried.
I was about to say, you hire people, or you just get on the cloud. You tried Google first?
We did. We tried Google.
Maybe at the time it was less mature. Maybe it was less mature at the time. What do you think?
I don't know why, to be honest. I was familiar with AWS. I had an account already, and I'd spun up some EC2 instances just to play. But I was intrigued by the idea that Google did the same thing. So we spun up some GCP instances. We played with it a little bit. And I can't remember off the top of my head what really turned me off. But in the end, I canceled all that Google stuff.
GCP took a while to be mature. Now it's great, but
everything
it did take a while to be really. Yeah,
everything that I
still
did
is
Google, everything was listed as beta, and I was like, well, how can I base my business on something that you're listing as beta when you've proven that you've taken stuff that's beta, you've just taken it away without it going to production.
Not only that, not only at the time, but it's still like that. If you go, I do a lot of the speech recognition and similar stuff in Google, and if you go to the various documentation, the speech recog part of the APIs, they're all in beta. Like literally always says beta here, beta that. It's just okay, I guess. It is. It's scary. It is.
It is. But once we made the decision, it kind of all came together pretty quickly. It's really easy.
So once you went to Google, earlier, were you already running something? So the first style of container was really just virtualization with a different name.
Yeah,
did you move to Docker then, or?
Yeah, we did. We ditched containers. So when we left the data center where we were all containerized with LXC, decided to give every customer a micro EC2 instance instead, which was actually enough resources to run Asterisk, and not quite enough to run FreePBX. So we played with it a little bit and decided to go from micro to whatever the next one is, Tiny, I think. That's what we run today. So just about every customer has their own EC2 Tiny instance running FreePBX, which was super easy to set up. And we've got a dashboard web interface that we wrote to manage it all. The transition wasn't too hard, and I felt a lot better about individual customers having the resources dedicated to them. Timing, as you
Isn't that a bit hard to maintain?
No timing issues have ever really happened.
Like running separate VM, that hard to maintain.
Sorry,
or not necessarily. Isn't it hard to maintain one VM for each customer?
You would think so.
Wide isolation.
Yeah. And it is kind of what's pushing me to what I'm about to talk about. Because it is starting to
I know.
I'm starting to run up against some AWS resource limitations. We foolishly assigned Class C address spaces to some of the networks, right?
Okay, so
running out of IPs, which is a silly issue, and we can solve it obviously, but the lift is a lot bigger than you would expect.
It is.
So along the way,
what's your next step?
Yeah. So along the way, I've always been thinking in the back of my head that we're wasting resources, that we're paying for resources that we're not really using, right? And the containerization has come a long ways, and container management has come a long ways since LXC, which was basically non-existent management. So I kept thinking I need to look at it again, and Kubernetes kept coming up. I took a contract with a company where I'm doing a lot of Kubernetes work, and now I feel like I know enough to be able to design the system around Kubernetes that we want, and it's exciting me. So our EC2 based architecture, which is run nearly flawlessly, knock on wood, for years, actually has some serious issues. It has some serious single points of failure, which, again, knock on wood, haven't bit us yet. But we have, for example, one EC2 instance that handles VPN tunnels for every phone in our network, thousands of them. If that instance goes down, every phone in our network would be offline until it rebooted. And for God, if it didn't reboot, holy crap, we would have a full outage. Now we have some things in place to ensure that such a thing doesn't happen, right? We have snapshots of that instance that we could launch at a moment's notice. So I can't imagine such an outage ever lasting more than maybe half an hour, but it would be really stressful, and the fallout would be weeks long, from some of our customers that would be very upset. So I know that I need to solve this.
Yeah.
And we're solving all of these single points of failures in basically the same way. So here's an EC2 instance that handles all the VPN connections. Kubernetes way is to split that out into microservices, right? Rather than have one big monolithic server that handles everybody's VPN, I'm going to split out VPN containers. So here's the difference. A customer today gets an EC2 instance that runs everything.
Yeah.
It's got a MySQL database on it. It's got a web server on it. It's obviously running Asterisk.
It's isolated.
It's isolated. And that is kind of Kubernetes-ish. But what I don't want to do is just take that monolithic monster and launch it as a container. That's kind of what we did before. But I would rather split it out and do it the real microservice way, right? So today you get an EC2 instance. Tomorrow you're going to get a pod, a Kubernetes pod. So in Kubernetes, a pod is like a collection of containers. So in this sense, you're going to get 4 containers. You're going to get a VPN container, an HTTP container, an Asterisk container, and another container that runs TCP dump. They're calling this one a sidecar. And the sidecar is basically watching the traffic coming in and out of the pod, looking for phone calls. And when it sees our TCP traffic, which is kind of SIP's way or RTP's way of tracking call quality, this little sidecar is going to watch that traffic, pull out that quality information, and stuff it in a database for later. So all of this is going to be the customer pod that gets launched when somebody signs up. Now, if something happens to the host that's running that pod, Kubernetes takes care of saying, oh my gosh, that host just died. It was running these 10 customers. I'm going to launch those 10 customers on this other host over here, because it's available and has resource. And everything will just work. So
you're still completely multi-tenanted and segmented. It's not shared, nothing. It's just that it's now what's shared is the underlying resources.
Right. So everything
I'm curious. Do you use underlying EC2 instances? So you provision almost physical like boxes, or is it the complete managed Kubernetes that Amazon offers? Just curious.
So at the moment, we've only got a dev cluster spun up, and our dev cluster is EC2 instances, and they're shared instances. So it's kind of like
those are
double share, right?
I'm asking because the managed Kubernetes and managed Docker on ECS, EKS, whatever you call it, it's super expensive. Like I haven't been able to find a way to truly use that without. I mean, it doesn't at that price point. It doesn't make sense to use it.
I'm going to give you a trick because we went through all of this. We started with, hey, let's use every single possible service AWS can offer to make this easier, and construct our design around that. And that's what we tried first. And holy shit, was it expensive! So we used CPS to launch the instances. There were weird charges for things we couldn't explain. I contracted consultants to look through the billing records to try to tell us why this was 3 times more expensive than we thought it should be, and they couldn't answer it. Like their billing is so detailed, and there were thousands of billing records associated with what we were trying to do, and we hadn't even launched a customer in it yet. It was literally just the base stuff. So I totally ditched all that. There are a million tools out there to help you construct clusters. We've tried a bunch of them. We went with Rancher for quite some time, thinking that was going to be the way forward. And then I got really turned off by a phone call I had with their support people. I wanted to do it right. I wanted it supported. I wanted somebody to be able to call. And their minimum buy-in was $70,000 a year to support one cluster. And I was going to have multiple clusters. And when we started talking about the options that I really wanted as part of the support, my bill was like $250 or something. Like, there's no way I'm paying $250 just to license your support. So Rancher went out the window. What we ended up with is something called COPS, KOPS. So COPS is good because you can define your cluster with a manifest, which is basically you write a single text file that fully describes your nodes and where you want them running and how you want them to connect and whether you want them public or private. And there's all kinds of things that it can automatically launch for you. Basically, run one command and poof, it goes and creates all this AWS objects for you. And none of it has anything to do with AWS's extra services. You literally only pay for the EC2 instances and then whatever traffic you're flowing, out its public gateways. And then I think I'm paying for an internet gateway, load balancers for the ingress, which is the one thing I'm struggling with at the moment. Not to get too deep in the weeds, but there are 50 ways you can bring traffic into a Kubernetes cluster, and they're all extremely complicated. And then you put AWS in the middle, and it gets worse. Because AWS is pretty strict about how to get traffic into and out of EC2 instances. They're forced to use their load balancers, and load balancers have restrictions. To give you one example, RTP, right? RTP requires a large number of UDP ports to be exposed in order to have a lot of conversations simultaneously. So my head-end Asterisk servers that are connected to our carriers, they need 10,000 UDP ports exposed in order to do their job.
Yeah, those they do, yeah.
And if I'm going to do that through an AWS network load balancer, the configuration for that is impossible. I'm not even sure it would work. I don't think that their configuration would accept
Docker. If you run Docker by itself, it has a symbol where all the ports are actually exposed as a single process, a single rule in IP tables. So if you set up a port range like classic 16,000 to 32,000 for RTP,
right,
it's actually trying to spin up 16,000 IP tables rules, and it takes 15 minutes to start. It works, but it's so slow, and it messes up everything else that's happening in the machine in the meantime, which is the worst part.
So I'm actually considering right now that I'm gonna publicly expose the nodes that are running what I'm calling our dial tone service, and those UDP ports will just be exposed. I don't really see that as a security concern. It will be filtered down to just those UDP ports, of course. I don't like that, I don't think, but I think it solves my issue. But this is kind of the state that we're in, right? We're still experimenting a little bit and playing with things. But my trick for you was COPS. If you still want to play with Kubernetes on AWS, COPS is super easy to launch a cluster and cheap. Like our dev cluster is only, let's say, 6 EC2 nodes, all mediums.
I'm gonna have to try. I am a Docker expert, I would like to say. I've done a lot with Docker and Docker Swarm, which we run internally and use it for everything else. But yeah, Kubernetes is probably more mature at this point. It's a technology that needs to, and we're starting to use Kubernetes internally too, so I probably need to start understanding that. It is a quite nice piece of software, though it's complicated. Yeah, my solution for Docker was really, so you have two ways. You either do the host networking, which is fine, and Kubernetes has it for pods, or you can try using IP tables, which actually work well. So if you want to run your containers as in host mode, just expose the ports internally. Don't expose them to the actual interface, and then use IP tables to bridge the two, which is much easier because IP tables does support ranges. You can tell it from here to here. It will reach. That's a short version. It's actually complicated, but not by much. So maybe you can try that.
That should be enough for the container. Exposing the ports in the container isn't really the hard part. It's more how to tell AWS to let that stuff in. That's the hard part.
Oh, you're right. Yeah, if you're running on a machine that has a public IP, it's just IP tables. You can do it.
True.
If you're running on AWS, and you start by telling AWS that it's okay, and then going down from there, it's not. You're right. It's not super straightforward.
Yeah, I'm actually
AWS's networking, not my favorite.
Like another problem that I'm trying to solve. I really want to run a single VPN container for every customer, which means that I've got to have a path to that VPN server from the outside somehow that they can reach. That either means that every customer gets their own IP address, and then I use a standard port for them to reach the VPN. And I don't like that too much because that actually costs money. I mean, I'm doing this to try to reduce my cost per customer, right? And I want to say my cost per customer running our EC2 architecture is somewhere around $15. I think that I can get that down to almost $3 with our Kubernetes architecture. And if I add an elastic IP per customer, that's another $3. It's doubling the cost of the customer to add an IP address. So I've kind of convinced myself that I'm going to go to port range instead. So as a customer, you're going to get a UDP port. And of course, they'll never see it. This will all be pushed down to their devices automatically and such. But the idea is that I'll separate them by port, which does limit me, right? So I can only have at most maybe 30,000 customers this way. I doubt I'm going to actually hit 30,000 customers before we sell or do something. So I'm sure that's too much of a limitation. So I think that's what I'm going to do. So now I've got to have something listening on that range, that large range of ports, and passing the traffic into the correct Kubernetes node, which is going to be difficult to figure out. And I don't think I can do any of that with a network load balancer. So I'm going to have to run something on an EC2 instance, I think, to be my network load balancer, but it'll be something custom to be right. And I think it's probably going to be based on a package called Traffic. Traffic is kind of a...
Oh, yeah, I've seen that. I've seen Traffic.
I think I'm going to use that. So I'm running Traffic on a pair of EC2 instances that, will back each other up with HA proxy or something. And their only use will be to forward these UDP ports into the cluster.
Yeah, the forwarding is the main problem when you're running like Frizzwich or Asterisk. So again, host mode is fine if you're running a small server. Don't worry too much. Just go for host mode; it works. But if you're trying to build an infrastructure of your size using the host firewall, so whatever's on the machine is the only way. Since you do have an IP address, so you can always set up IP tables rules. Just try that. It's the only way.
That's true.
At the cluster level, it could probably be done from. Maybe you can even do it with AWS networking alone. That'd be interesting.
I think if I don't have if I expose the nodes themselves, then there's no network load balancer involved. The problem then becomes, so every node knows where customer pod is running. So if I hit node A on port 50,000, node A knows that port 50,000 is for customer A, even though it's running on node C. So even though it's slightly inefficient, traffic could hit node A, get routed internally in the cluster to node C. But I'd like to avoid that, right? So you run what's called an ingress, and traffic has this for Kubernetes also, where you run traffic inside the cluster. And because it's in the cluster, it knows where the pods are. And it should be able to expose to the outside that if you're trying to get to pod A, go straight to node C. That's the piece I'm trying to figure out right now. So if I publicly expose all the nodes, then by DNS round robin or whatever, you could end up on any of the nodes. And then in traffic internally would know how to route you to the correct node. That's going to end up with a lot of spaghetti,
You probably need to have
unintended traffic.
You probably need to have something like a sticky session kind of thing. Unless are these boxes still going to be one per customer? Yes. Or are you
not the boxes,
moving to a shared
pods? So each node in the cluster will we're hoping is going to run 30 to 50 customers. So we'll have hundreds of these nodes.
Those balancing those are easy at all. It's I mean, there's some spot where you might be want to drop a kind of Camellia into the mix,
Yes,
something like.
we have thought about putting Camellia in the very front of all of this. It doesn't really solve my VPN problem. I'm trying to figure out what problem it does solve, to be honest. Because as far as the dial tone service is concerned, I don't care that I have got 100 nodes that are exposed publicly, because any phone that makes a phone call that goes out one of those nodes is going to hit my carrier. My carrier knows all of the nodes that are allowed to send calls to it, so that's not an issue. And calls that come back the other way, they're going to hit by DNS round robin. They'll hit any node, right? But any node has the dial tone service running on it that knows where the customer is that needs to take that call, so it'll pass the call to it, even if it's on another node. Again, this is going to end up with kind of a spaghetti of nodes calling other nodes and a lot of internal cluster traffic that's not necessary. Is it a problem? Like, these are such high bandwidth links that maybe it's not a problem. Kind of like the timing
I think
issue,
in general,
right? Issue wasn't a problem.
Yeah,
Theoretically, it was a problem, but it turned out that it didn't actually happen. So I'm kind of.
I feel like you might be very much right. I feel like you might very much right, and I think the time analogy is pretty spot on. Like, we were all convinced voice could not work on VPN on virtual machines until someone came from the application world like me and just, well, you know what, I'm just going to run it because it's what I do all day, and it worked because I wasn't doing anything fancy. I think the timing really had to do with hardware and T1 interfaces and ISDN and all those cards. Those needed very specific stuff, but a virtual machine doesn't have any of those.
Right.
Like, you technically can work.
There's going to be cracks in the audio. It's going to be terrible.
Yeah, for sure. But in general, it worked very well. Well, I mean, Kubernetes is always a fun journey, and I think you're, slowly moving to that. My not closing, but I mean, my general remark about Kubernetes is that sometimes I feel like Kubernetes is in its own a cloud system. Like, it's almost something you should run in play instead of AWS. I don't know how to put it. Like, it's kind of like OpenStack. Like, I've seen people running OpenStack on AWS, and my question was, why? Like, you're running OpenStack on AWS. Why are you running AWS on AWS effectively? So in a sense, Kubernetes feels like it's actually more at home on some very neutral deployment situations, such as just DigitalOcean and bare VMs, where IP addresses are public by default and everything is pretty simple, and you set it up. So look into that too. Like, there's a couple other hosts, not only DO, but DigitalOcean is the main one, that offer just plain VMs which have a public IP address, and that's it. And you're on your own. Might be a better, more suitable way to. I'm saying this out of experience. I've been trying Kubernetes, and I felt like I was fighting AWS and Kubernetes at the same time. Testing on DigitalOcean made me one enemy at a time.
You are not wrong. In fact, that's where EKS CTL came from, because AWS had to make it easier to run Kubernetes, because it is not easy.
No, you're fighting both of them.
No, you're not wrong.
Well,
in fact, I have considered moving back to a data center. I feel like that I'm experienced enough with setting up Kubernetes that I could do it on bare metal, which is what I managed with this other contract I'm working. It's all bare metal in it, so I'm kind of comfortable with that.
Bare metal Kubernetes is very interesting to me, because I feel like that is where it should be. Again, Kubernetes replicates an entire, not even a computer, replicates an entire network of systems by itself. So why run it on another network of systems that's managed by yet another network of systems? Just do bare metal or
silly. It does.
And go from there.
Even 2 a.m. phone calls. However, this would be a different story, because, and I felt this was a great quote from the AstraCon conference in January. There's a guy that gave a Kubernetes talk before mine, and he said that the big switch for him was treating his servers like cattle instead of pets. He says,
Oh yeah,
when
that's a
you're running a data
very
center, right, and you spin up a machine and you install a bunch of software on it and you configure it, and you know, there's history now built into that box, and if it dies, like recreating it's sometimes difficult, even with backups and snapshots and whatever. But in the Kubernetes world, you really don't care. Node dies, and the cluster merrily continues on, and everything gets restarted that died, and nothing happens. A customer might drop a phone call, but if they call right back, that should be enough time. Like, it'll spin up that fast. But the customer pod spins up ridiculously fast, like in 5 seconds.
well. It's not by accident that Kubernetes and Docker before Kubernetes ate all of the lunches for the various configuration management systems, such as Chef, Puppet, etc.
Yes.
Even Ansible, they're pretty much gone. Like, those are. I know some people use Ansible to run Terraform effectively. So I need a new node. Great. Ansible is an easy way to specify the starting situation for that node. So install Docker and a few other things, but really just a few other things. Then you just bring in Compose or Kubernetes and you do the rest. So it's just much easier. I don't even know. I wouldn't even need that anymore. I haven't done a machine rebuild in years, like literal rebuild. Like, oh snap, this VM is gone. We need to do it to rebuild it again.
Right.
Spin up another Docker container, point the domain name, and maybe do a quick go pick up the database backups which you have stored somewhere in the meantime, etc. And it really just never breaks. It is much better.
Yeah. Just as we're talking about Kubernetes, even what I've described to you is not the Kubernetes way.
For you?
I am still, even though I've broken it out into containers inside of a pod, I'm still doing the monolithic kind of, I now have to run these nodes forever. They don't spin up and spin down with traffic, right? These nodes are running 24/7. The customer pod is running 24/7. That's not the Kubernetes way. So the guy that gave the talk before me blew me away. He has fully embraced, I'm not even going to tell you the company names, I'm not going to give them any free press, but they've fully embraced the Kubernetes model. And let me try to explain how their system works. Now, keep in mind that they have exactly the same target as us: hosted PBX systems, small companies with phones on their desks making phone calls, maybe cellulars as well, right? Same exact model. For them, they spin up nodes, Kubernetes nodes, on Google Cloud. So they went Google. Their nodes run asterisk with very special dial plans. Now, let's say that you're phone one on company A calling phone one on company B. They're both members of this service. So your phone call hits some random asterisk server, and actually they've got it. So you actually end up hitting the asterisk server closest to you, which is geolocated and all of that. So that's cool. But you hit that asterisk server, and that asterisk server knows who you are, what company you're associated with, what extension your device is associated with, and it sees that you're trying to call this particular number. Well, it knows where that number is supposed to be routed to, what company it's associated with, and the logic that is required to answer that call. So it goes ahead and does that, right? Pulls the IVR recording from wherever that needs to come from and plays it. Knows the logic for that IVR, so does the logic, right? Eventually ends up calling the other phone, and it knows where that phone is. It knows which asterisk server it's connected to, and it knows geolocation. So it makes the absolute best path between them, right? And that's all done with Chameleon. And it connects the two. There's no PBX. There's no running process anywhere that is company A PBX and company B PBX. It doesn't exist. It's all embedded in the logic in the cluster. There's not even any persistent storage. I was just completely blown away by this. So what happens in their network is during busy hours, they have lots of these Astra servers running. And then at night, when no calls are happening, they spin down. That's the Kubernetes way. Now, they're very generous. They put all of this stuff up on GitHub. And he talked through it in his talk. And I was just thinking to myself, my God, the work that was involved in this. And the fact that it's functioning is amazing to me. And I would love to reproduce it, but that's just a complete 180, from how we do things.
Yeah, even more moving to servers as disposable resources. Like at that point, just running workloads and you don't care what's there. The system will provision whatever is needed, take it down when it's not needed. It is pretty.
Isn't that crazy?
Yeah. At some point too, I'll counter that. At some point too, since established that running your own EC2 instances is so much cheaper, there's no point in running and managed stuff. At some point, you do have idle capacity sitting around because you're running the servers. So over optimizing something just for the sake of it might not net you much advantage other than configuration advantage, because frankly, you're still paying for the servers. So in an ideal world where there was a host that will allow you to run pure Kubernetes loads, as in a pod goes away, you're not getting billed for it anymore. And probably AWS is like that, but they're horribly expensive, so you cannot really use them for that. Aside from that, then at some point having some persistence is probably still easier. Still, maybe someday things are moving fast, so who knows?
Yeah, I just loved his solution. It scales to millions of customers, I think, and globally.
Oh yeah, it's plus anywhere you need some more traffic, just jump over there, add a pod or two, and it will just run itself. It is. I mean, in general, it's amazing what we can do these days. It's without even going into the software-defined network aspect and all of the other finer points of virtualization, which are super interesting to me. You can do a lot of super cool stuff, and look at. It's even creeping into.
You want to have me on again? We can talk SDN. We have an SDN product we're working on also. It's called Underpass.
Yeah, it's and it is creeping into the radio space, even like SDRs and 5G networks, etc. Effectively, are software-defined networks, so software-defined radios. It is. There's a bunch of. We're getting there. It's just a matter of. It has to be cost-effective, though. That's what I'm saying. That just getting a new toy for the sake of. It's not always the best solution when it's a lot of money. Again, running things for. I have established that running I was working on a workload that involves FreeSwitch and a few other pieces, and running it in managed Docker, like the Docker version of the managed Kubernetes on AWS, is 6 times as expensive as running off EC2.
Oh, really?
So for now, not for now. That's going to stay for an EC2 for a while. Well, Jeff, thank you very much for joining us today. It was a pleasure talking to you. It's not always we have someone who has experience with Kubernetes, and it is such an interesting and complicated aspect of today's technology that your contribution was very, very welcome. Thank you so much.
Yes, absolutely. I have fun talking about it, obviously.
And I hope I see you maybe at ClueCon, which is going to be in August from Chicago, from the 14th to the 17th this year. And website is ClueCon.com, and anybody wants to look it up. And there's going to be a lot of interesting talks. So I'm certain some Kubernetes stuff will pop up because it's always interesting. And I'll be happy to meet you there. And again, Jeff, thank you for joining us.
Chicago, I'd have no excuse. So yeah,
then you have to come, right?
Yep.
Okay, so come say hello. And Jeff LaCoursiere, CTO of StratusTalk, joined us today. Thank you so much.
Thanks.
And for the rest of the people, I'll see you next week as usual. Goodbye.